Hello everyone, welcome back to Scifun Academy, where science is made fun. Today, we are zooming into the teeny tiny world of atoms and Dalton's atomic theory. So, we ended part 1 with Lavoisier and Proust giving us two important laws of chemical combination. This was a big breakthrough, discovered through careful experiments. But there was still a big question. Why do these laws work the way they do? Enter John Dalton, a British chemist who loved puzzles, and this was a big one. Dalton looked at the old Greek idea that matter is made of tiny indivisible particles called atoms, and he developed a theory, a set of ideas, to make sense of it all. All matter is made of tiny particles called atoms. They are the basic building blocks of everything around us. Next, atoms cannot be broken down, created, or destroyed in a chemical reaction. They are indivisible and indestructible. Well, later scientists discovered subatomic particles, but this was Dalton's belief at the time. Atoms of the same element are identical. They have the same mass and same chemical properties. And atoms of different elements are different. They have different masses and different chemical properties. And finally, he stated that atoms combine in fixed whole number ratios to form compounds. For example, water always has 2 hydrogen atoms and 1 oxygen atom. Dalton's atomic theory helped explain the why behind the laws. Why matter is never lost in a reaction, the law of conservation of mass. And why compounds always form in the same ratios, law of constant proportions. He gave science a new lens to understand the hidden world of atoms. Well, so what is an atom? You know how buildings are made of bricks? Or how an anthill is made of tiny sand grains? Well, everything in our world, yes, everything, it's made of atoms. They are the tiniest building blocks of matter. In fact, they are so tiny that even millions of them stacked would barely be as thick as the sheet of paper. You can't see them with the naked eye, but atoms are everywhere, even in the air you're breathing right now. Next, let's look at how we name these different atomic elements. Now, Dalton had his own secret emoji language for the elements, which was very confusing. But later, a scientist named Berzelius said, "Hey, let's make it simple. Use letters from the element names." Okay, modern rule time. Symbols use 1 or 2 letters. The first letter is always capital. And if there is a second letter, it's small. Here are some examples. H for hydrogen and O for oxygen. Big A and small l for aluminium, not big A and big L. Same for cobalt. Big C and little o, not big C and big O. That's carbon monoxide. And some symbols come from their Latin names. Like potassium is K from calcium, and iron is Fe from ferrum. Okay, next let's talk about atomic mass. What does an atom weigh? Remember floof from part 1? Well, let's explain that properly now. Now, Dalton theorized that atoms have mass, and atoms of different elements have different masses. But how do we measure something so tiny? Let's take the example of a fruit seller who forgot his weights for his scale. But he still needs a way to compare how heavy his fruits are. What does he do? Well, he has an idea. He takes a watermelon and slices it into 12 equal parts. Now he uses one piece of watermelon as his standard fruit mass unit, or FMU. If an apple feels as heavy as one watermelon slice, then the apple's mass is 1 unit or 1 FMU. If a mango feels like 2 slices, then its mass is 2 units or 2 FMU. So scientists had the same problem. They couldn't use standard weights to weigh an atom. It was far too tiny. So they decided to choose one atom to be their standard fruit, to measure other atoms. But which atom to pick? At first, they considered hydrogen, the lightest atom. But it was just too small, and being an extremely light gas, it was very tricky to measure accurately. Then they moved to oxygen, which was heavier and easier to use in chemical reactions. But oxygen came in different forms, called isotopes, and that made things messy and confusing. Finally, they found the perfect candidate, carbon 12. Carbon 12 is stable and solid, and 99% of all carbon on Earth is the C12 type. Bingo! So scientists said, let's divide the mass of a carbon 12 atom into 12 equal parts. Each part will be called one atomic mass unit, or 1U. Just like the fruit seller could now compare all fruits, scientists could now compare all atoms using carbon 12. Hydrogen feels as heavy as one slice, so it's 1U. Oxygen feels like 16 slices, so that's 16U. Easy, right? Now, how do atoms exist? Atoms don't like being alone. They are social. So they team up to form molecules. Molecules then gather in huge numbers to form the stuff we can see, touch, eat, and even play with. Okay, quiz time. Here's our first question. Who came up with the atomic theory to explain the laws of chemical combination? Lavoisier, Proust, Dalton, or Berzelius? You guessed it, Dalton. He loved puzzles, and this was his biggest one yet. Question 2. According to Dalton, atoms of the same element are like A. Twins, B. Opposites, C. Clones, or D. Different every time. It's A. Twins. Atoms of the same element have the same mass and same chemical properties. Okay, next. What is the best reason to explain the law of conservation of mass using Dalton's theory? Is it A. Atoms disappear during reactions, B. Atoms are created from energy, C. Atoms are indivisible and not destroyed in reactions, and D. Mass is just a suggestion? It's C. Atoms are indivisible and not destroyed in reactions. The next one is a fill in the blank. Water is always made of dash hydrogen atoms and dash oxygen atom. Water is always made of 2 hydrogen atoms and 1 oxygen atom because atoms combine in fixed whole number ratios. What does one atomic mass unit, or U, represent? Is it mass of one nitrogen atom? Mass of one proton? 1/16th the mass of an oxygen 16 atom? Or 1/12th the mass of a carbon 12 atom? It's D. 1/12th the mass of a carbon 12 atom. Which of these symbols is written correctly? Is it little a and little l for aluminium? Or big C and big O for cobalt? Big C and little l for chlorine? Or little n and big A for sodium? It's C. Big C and little l for chlorine. For aluminium, the first letter should have been capital. For cobalt, the second letter should have been small. And for sodium, both the rules are wrong. Question 7. True or false? The correct symbol for iron is I. False. The correct symbol for iron is Fe, which is Latin for iron. Okay, the last one. Match the element to its symbol. Nice job. Sodium is Na, potassium is K, hydrogen is H, sulfur is S, and helium is He. Amazing, guys. Next, let's look at some key takeaways from this video. The first one is that Dalton's atomic theory explained the why behind chemical laws. The second, atoms are tiny but powerful building blocks. And third, atomic mass unit makes weighing atoms possible. In the next video, we will be learning about molecules. And that's it for today, folks. Thanks for watching. If you learned something new today or just feel smarter than you were 5 minutes ago, hit those like, share, and subscribe buttons and stay tuned for more mind-blowing science. See you in the next one.